schematic of the rotation of the bead and the drilling. You see that after running a casing, we use a smaller bead size to continue a drilling and drill another hole. After that, this is maybe complete as an open hole, like a barefoot. For the barefoot completion, you just pull out the string and start the production. This is the barefoot. Or maybe run some of the slotted liner or the perforated liner to complete a well, and this is another type of the completion. Another type of the completion is related to create a cement, do a cement job, and perforation. So it's about the barefoot completion. Barefoot completion have some disadvantage, like a zonal isolation. We have some limitation in the zonal isolation, maybe collapse of the hole, or maybe we have a sand production. This open hole completion after drilling just for a reservoir with the high well stability, with the high strength of the rock. Right now we want to speak about some of the damage due to drilling. During a drilling, we have circulated some of the fluid to the well. This fluid, because the well must be overbalanced to the reservoir pressure. This is the overbalanced condition. And the hydrostatic pressure of the mud is more than the reservoir pressure. So we invaded some of the liquid and some of the solid material of the drilling fluid into the formation. And this invaded of the solid and the fluid create some damage for the formation. And we as a production engineer, we must design some operation to decrease the amount of the formation damage by the acidizing, by the hydraulic fracture. This is about us to design a way to decrease amount of the formation damage. If we have a good relation with the drilling supervisor or the drilling engineer, we can manage this problem. During a bead rotation, because of the rotation of the bead, the heat at the bottom of the hole increase. And one of the purpose are using of the drilling fluid to decrease amount of the heat on the bead. So increase or cooling a bead. Increase the heat of the bead, maybe create some damage, means glazing and meshing. You see that if we have a heat, maybe have damage and effect on the formation. So also we must optimize the rotation of the bead to control the formation damage during the heat of the beads.
So the rotation for the bead starts from rotary table or motor by...
It's related to the type of the drilling. Maybe some rotation of the bead related by the top drive. Top drive and rotate. But maybe use of the Kelly. By the Kelly, rotate by the rotary table or Kelly bushing. Or maybe for the deviated well or the horizontal well, you use a special type of the pump. A special type of the pump like positive displacement pump. We have a RSS, we have a rotor and stator. And this rotation of the rotor and stator help to moving of the bead. But for this condition, we rotate from the surface. But in the many deviated well, many horizontal well, use of a specific motor to rotate a bead. Type of the drilling fluid also have an effect on the formation damage condition. Maybe based on the type of the damage, we choose a new one of the drilling fluid. Maybe oil-based mud, maybe use of the air as a drilling fluid, because we must, as a production engineer, we must control and decrease the amount of the formation damage. is for section about the barefoot or the slotted liner. But maybe based on the wellbore stability, we need to start cementing operation. We can do another. After finish a drilling, first we move up the string. We pull out the string and inject some of the cement. First, we run a liner, and through the liner, we design a cementing operation and cover all of the casing or all of the liner with the cement. This condition helps us to have a zonal isolation and control the amount of the unwanted water production. But at this condition, after the cementing, we have to create a pathway to production of the oil. So we want now to perforate, but also maybe have some of the problem due to the cementing. Maybe just this cement also create some skin factor. Also, maybe we have some problem due to the quality of the cement. For the analyze and evaluate the quality of the cement, we must use some of the special device. One, cement bond light, circumferential acoustic scanning tools, ultrasonic imaging, segment bond tool, radial bond tool. All of these tools help us to evaluate the cement behind the casing. If we have a bad cementing, during the production, we have a channeling of the water. So, and as you know, high amount of the water may be plug a well. So, first we must analyze the quality of the cement. After the finishing the cement, if we have some problem in the cementing, maybe based on the temperature and the pressure of the reservoir, we have a bad cementing operation. For the mitigation of this problem, we must use a cement squeezing operation. Cement squeezing operation means that we perforate a hole and inject the cement with the high pressure to the formation to cover all of the interval with the cement.
How can we create a hole inside the casing?
By the perforation. This is a very complicated operation in the drilling. In the cement squeezing, first you must set a plug at the bottom of the interval. Maybe we have some failure in the cementing operation at the above condition. At the bottom interval, you must first set a plug, like a bench plug or the cement plug. After that, we ask a wireline group to run a wireline with the perforation and create a one shot to create a hole or a pit in the casing. After that, by the coil tubing, we inject the high amount of the cement to inject from the one hole to cover the empty interval of the cement. This is the quick review of cement squeezing job to be sure about the quality of the cement. No, we now sure about the quality of the casing. We must create a pathway to production of the fluid. So right now, we must use of the perforation technique. You see that run a carrier. The drilling tools means a carrier, and the carrier have some of the gun. You see that we run a carrier with a cable. The name of these jobs is HSD. HSD. If we run a carrier with a wireline cable. After be sure that the gun and the carrier in the good interval, we activate with the wireline cable, this is the electrical cable. we activate the electrical by the surface command, by the wireline supervisor, and explode the sum of the gun and create the sum of the password. This is a HST job. By maybe we run a carrier with the tubing. In this condition, the explosion exploded of the gun activated by hydraulic forces. We have a shear pin also, like setting a plug, like setting a packer. And with increase the pressure, this shear pin is cut and actuated the gun, and the gun goes to the formation. You see that after the gun goes to the formation, also maybe we have a sum of the debris, because the casing is parked and we have a metallic debris. So as a production engineer, we must be design an acid washing process to clean the wellbore. The factor effect to the perforation design is the shot per foot, means the number of the gun per foot of the formation. Also, as a production engineer with industrial software, we must be design the shot per foot and the size of the gun for the good perforation job. After finishing the perforation and after acidizing, so we have a path to produce a morpholoid to the surface. And this is the cement bond. It is the cement completed of the bed. And the most common type of the compilation reservoir run a liner, cementing, and created the perforation and produce a fluid. But maybe we have some limitation. During the production, by the wax deposition, asphalting deposition, scale deposition, maybe this perforation is plugged. For also this condition, we must be mitigate by some of the inject of the inhibitor, some of the acid washing, or any other workover operation. Any question about that?